Yes. Now we will start Venn diagrams. What do you mean by Venn diagram? Venn diagram means it's a representation of set in terms of what? Figure. Correct? In terms of figure, or representation of set by a figure that is basic plane figure, rectangle, triangle, circle, anyone. Correct? So I can write definition like this. The pictorial representation of any set is called as Venn diagram. Remember this one. Pictorial representation of any set is called as Venn diagram. For example, check this. For example, number 1, if I have a set like this, 4, 6 and 8, then I can represent this set in a circle like this by putting this 4, 6 and 8 as 3 elements. Correct? And this is called as Venn diagram. One more example, if I have B set like this, A, E, I, O, U, then I can represent this like this also. Just check. If I am using the rectangle, I can represent it A, E, I, O, U. So these 5 elements I can put in the rectangle. So pictorial representation of any set is called as what? Venn diagram. Check next. Number of elements in a set. Okay. So number of, just check, number of distinct elements present in a set. Number of distinct elements present in a set is going to be number of elements in a set. Means what? How many elements present in a set? How? Just check. It is denoted by n of a. Remember, it is denoted by n of a. For example, if I have set like this, A, B, C, D, E, then I can write n of a as 5. Correct? N of a as 5, because how many elements present in this set? 5 elements present in this set. Correct? Next is important. Phi is empty set. You know this one? Phi is empty set. Then what will be n of phi? N of phi will be 0. Why? Because if the set is empty, the number of elements in the set are what? 0. Check next. Next is last one. N of a is also called as, check this, n of a is also called as cardinality of set. Remember, also called as cardinality of set. Remember, this number of elements are also called as cardinality of set. So these two are most important concept we had. We will start now operations on sets. Okay, operations on sets. पहा कशी operations करायचेत. How to do these operations. Check this. So the first operation is complement of a set. Check how to work on this one. Let me consider this as a universal set. I will consider the whole as a universal set, and I have one more set, and I will call that set as A. I have one more set A. Then what is complement? Complement of a set means if I want complement of A, that means I want elements other than A but in U. That means universal set. That means I want elements excluding this, that means other than A but in U. That means can I shade this portion, and this will be your correct Venn diagram. I'm just shading the elements which are not in A but in U, and that is called as complement. For example, can I write like this? X such that X belongs to U but X does not belong to A. Correct or not? The elements are in U but not in A. I repeat, elements are in U but not in A is going to be what? Complement of a set. So remember, complement of a set means elements are in U but not in A. Correct? Check next example now. I have U set 1, 2, 3, 4, 5, 6, 7. I have A set 2, 3, 6. Then complement is noted by these three things: A dash, AC or A bar. Everything is complement is going to be, just check, complement means elements which are in U but not in A. That means exclude 2, 3 and 6. 2, 3 and 6. So what left? 1. Then 3. Correct? No, 3 is there. Correct? 3 is there. So I will exclude 3 also. 1. Then 2 there, 3 there, 4. Correct? 5, 6 is there, and 7, and this is going to be your complement of a set. Remember, this is going to be your complement of a set. Check next operation. Next operation is union of sets. Again, I will consider this as universal set, I will consider this as a set A. Okay, this as a set A. Consider this as set A, and I am considering one more set as set B. One more set as set B. Then what do you mean by union? Union means, I repeat, union means combining both. That means we want elements of A as well as elements of B. That means I can just share this like this, and this is going to be your union of set answer. Correct or not? So denoted by what? Union means combining both, denoted by A union B. Denoted by A union B. How to go for this? Just check. A union B is equal to X such that X belongs to A or X belongs to B. That means X is in A or is in B, and the union is going to be what? This one. So elements which are in A, which are in B, both together, that will form what? Union set. Correct? Check next. Example. I will denote this by A union B. Union means combine all elements together, A, B, C, P, Q, R, S, and that is going to be union. So what's complement? Complement means excluding these elements. Union means combining this element plus this element, and that will be what? Union. Now last one is intersection. This one. Check intersection now. Intersection again is, this is universal set U, this is set A, and this is set B. Then what is intersection? Intersection means elements which are common to A and B. That in A and in B, both together will form what? This one. Correct or not? But here it is not so. We want elements in A which are also in B, or elements in B which are also in A. That means we want a common set. We want a common set, and the common set is here. Correct or not? And that is what? Intersection. That is what? Intersection. So I can denote this by A intersection B. I can denote this by A intersection B, and I can write this in set form like this: X such that X belongs to A and X belongs to B, not OR. Here it's OR, here it's and X belongs to B. So X is an element of A as well as element of B, and that is called as what? Intersection. Correct? Now check example. What's the common? Common is intersection. Can you tell me common in this? Common in this is 6. Only 6 is the common element. Rest all are not common element. So this is intersection. So everybody understood this? I will denote this all again. This is complement A dash. This is A union B. Correct or not? This is A intersection B, which is common here. Clear? These are the basic 3 operations. There is one more operation, 4th one. Start 4th operation, that is difference of sets. How? Check this one. So difference of set A and B is a set of elements, in A but not in B. Correct? Set of elements which are in A but not in B is called as what? Difference of A and B. For example, it is denoted by A minus B, which are elements which are in A but not in B, is going to be denoted as what? A minus B. Denoted as what? A minus B difference. How? Check this. I will show here how to show this A minus B. Check this carefully. I have this as union set. So universal set U. Correct? I have now A and B also. This is A, correct, and this is B I have. Then what is A minus B? Elements which are in A but not in B. In A means here but not in B. That means elements which are in A but which does not belong to B. Which are in A but does not belong to B is going to be difference of A minus B. So which are in A but does not belong to B. What if this is exactly opposite? What if this is exactly opposite? That means B minus A. Check this one. Again, this is universal set U, correct? And I have set A here, okay, and I have set B here. Again, check. I want B minus A means elements which are in B but not in A. Correct or not? Which are in B but not in A. Which are in A but not in B. Which are in B but not in A. Correct? Which are in B but not in A. So this is going to be what? B minus A. Got it? Everybody got this one? So this is elements which are in A but not in B, that is A minus B. Observe only A. Elements which are in B but not in A, observe only what? B. Clear? So this is what difference of the set. How to write this? Check. I am going to write A minus B now. Can I write like this? A minus B is equal to X such that X belongs to A and x does not belongs to B. Does not belong to what? B, because x such that x belongs to A but does not belong to what? B. Next, B minus A. How to write B minus A? Same. X such that x belongs to what? B. Correct or not? X such that x belongs to B and x does not belong to what? A. So which are in B but not in A. Clear or not? So this is what the definition of A minus B and B minus A. Can I write like this? Just check. This is universal set. Carefully, huh? I have this set A. I have this set B. Check carefully. I have this set which is A minus B. I have this set, and if you know, this is B minus A, and I have this set, correct, which is A intersection B. Then can I say A union B is union of this and this? Yes, all together is going to be what? A union B. So can I write like this? First union, second union, third. What is first? A minus B. What is second? A intersection B. What is third? B minus A. If you take union of all three, you will get what? A union B. This is what? Second part of this difference of a set. Check next. Next is symmetric difference of A and B. Check next. Symmetric difference of A and B. How? Denoted as A symmetric difference B. This is what notation. A symmetric difference B. How to write this? Just check. A symmetric difference B is equal to A minus B union B minus A. So it's union of A minus B and B minus A. How to denote in the figure? Just check. This is universal set. This is A. This is B. Correct? And now check what is going to be A minus B. This is A minus B now. This is A minus B, and this is, check this one, this is B minus A. Correct or not? And union of these two both is going to be A symmetric difference B. Remember, this is symmetric difference of any two sets, and this is all about basic operations. First operation we did was complement, second is union, third is intersection, fourth is difference, fifth is symmetric difference. Here we concluded all basic operations of sets. Next point is cardinality of set. We already have discussed what is cardinality of set. I will revise it once again. Cardinality means number of elements in a set denoted by n of A, correct? For example, I will give example again. I have a set like 2, 3 and 7, then number of A are 3. Why? How many total elements in the set we have? 3. So that is called as cardinality of set, but we have these properties, and if you remember, you did these all properties in previous standards also. Check. So what is n of A union B? N of A plus n of B minus n of A intersection B. Remember this formula. N of A union B is n of A plus n of B minus n of A intersection B. Remember, if A and B are disjoint sets. What do you mean by disjoint set? If sets having no common elements, these sets are having no common element. If there is no common element, what will be intersection of these sets? It will be 0. Correct or not? I will put this intersection 0 here. So I will get A union B is equal to n of A, correct, plus n of B. Why? This intersection is what? 0. Correct or not? You can denote this as this one also. Mod of A union B is equal to mod A plus mod B instead of n. Remember, you can denote it like this also. This is first theorem you need to remember. Correct? Second theorem is this one. It will be n of A union B union C is n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C plus n of A intersection B intersection C, and that is going to be A union B union C. Remember this one. One more theorem we got. N of A plus N of B plus N of C minus N of A intersection B minus N of B intersection C minus N of A intersection C plus N of A intersection B intersection C. This is n of A minus n of A intersection B. Remember this one more formula. Next is n of B minus n of A intersection B. Remember, here it is B dash, here it is A dash. Clear? Check next. If n of A is m, then n of P of A is 2 raised to m. My question is, what is P of A? It's power set. If you remember, powers of set A, correct or not? What is power of set A? All possible subsets of that set of all possible subsets of that set is power set, correct? So 2 raised to m. Remember this. If A and B are finite sets, then n of A minus B is n of A minus n of A intersection B, and that's the answer. These are important properties of cardinality. I want you to write this everything in notebook. Here we concluded basic theory, and now we'll go for algebra of set operations. Remember this. Yeah, we'll start now algebra of set operations. Check how. First is idempotent law, correct? What is idempotent law? A union A, that means this is same set, its union will be what? A intersection A, again the same sets, that means you are going to get same thing here, correct? Then commutative, A union B is B union A, that's a commutative thing, correct? A intersection B is B intersection A, B intersection A, remember this one, clear? Check next, associative, A union B union C is A union B union C, that means if you write B union C together and then A union, and if you write A union B together and then union C, answers are going to be same. Same here, A intersection B intersection C, just change of brackets will not change answer. A intersection B intersection C is A intersection B intersection C, clear? Check next, distributive law, and this is most important law. Remember, this is most important law. This is most important. We need this everywhere. Huh? Check this one carefully. A of A union B intersection C is A union B. A union B intersection A union C. A union C. I'll repeat this once again. A union B in the first bracket intersection A union C. Correct? That means send this A with B first and then send this A with C. Correct? Check next again, intersection. A intersection B union A intersection C, same. A first with B, A then with C. Clear? Check next, identity law. What's identity law? A union phi. A union phi is A. Why A union phi is A? Because phi is empty set. So again you are going to get what? A. A union U. U is universal. Universal with A is what? Universal only, because that's the basic set, correct, or set of all sets. A intersection phi is phi because there is no common between empty set and A set, nothing common, no common things, so phi. A intersection U, check this, A intersection U, so intersection between A and U is A itself, correct or not? Between A and U is what? A itself, correct? Check next. Next is involution law or double complement law. A transpose transpose, transpose means complement right now. So A complement and again complement will give original A. You know this one, correct? Last, sorry, G now, complement law. What's complement? A union A complement is universal set. Why? A and a complement is rest all thing. Together is union. Is not union, universal. Universal complement is phi because there is nothing outside universal set. So complement is phi. A intersection A complement is phi because nothing common or nothing intersection between, nothing in intersection between A and A complement. These are two different things. Phi complement is union. Correct? Again, next absorption law. A union A intersection B. I have A intersection B in union with A. So A intersection B will have a common part, correct or not? With what A is going to be what? A itself. And A intersection A union B. So from A union B and A, I want common section. That will be what? A. You can just draw these Venn diagrams. If you have doubt, you can ask me. De Morgan's law. What is A union B? A dash intersection B dash. Just change everything. A dash intersection B dash, you will be what? Intersection. Next, A intersection B is A dash union B dash, and again this is most important law, correct? We need this everywhere. So these are all important laws. That means algebra of set operations. Clear? Yes, write this quickly. Yes, one more theory point we will discuss. Principle of duality. Nothing difficult, easy. Check how this works. In any proved result, just replace universal, that means you set symbol by empty set into bracket phi and union into bracket u symbol by intersection symbol intersection. Replace universal by phi and union by intersection to get corresponding dual. I repeat, replace universal by phi empty set and union by intersection to get corresponding dual. How? Just check this example. I have A union A dash complement is equal to universal set, correct na? A and A complement union is universal set. Now dual is A intersection A complement is phi. Just check. Union is replaced by intersection and universal set is replaced by empty set. Why? Because intersection of A and A complement is phi. This is just proof of basic result using what? Dual property. Correct?